Right. So let's go on and look at these different questions. The first one here, we've been told let x minus 2 be a factor of f of x, where f of x is x to the power 3 minus x to the power 2 plus ax plus b. Find an equation satisfied by the constants a and b. Okay, satisfied by the constants a and b. Now remember, they've told us x minus 2 is a factor of f of x. What it means is that when you get x minus 2, you take it into f of x, it will go there completely. That's the meaning of a factor. If I say 2 is a factor of 4, meaning that 2 can go into 4 without leaving a remainder, meaning the remainder is 0. So we're going to use the the factor theorem. Using the factor theorem, we know that remainder is equal to f of a, right? Now, because x minus 2 is a factor, meaning that the remainder we're going to get is 0. And that is going to be equal. So what you do is just get this factor. They've given you x minus a. Sorry, not minus a. This is now x minus 2. That factor, equate it to 0. You find the value of x. So x is equal to 2. So this value 2, go and put it in f of x, because we are saying remainder is equal to f of a. So a in this case is representing 2. So that will be 2 to the power 3 minus 2 to the power 2, and then plus a multiplied by 2, and then plus b. And this is going to give us 0 is equal to 8 minus 4 plus 2a plus b. 8 minus 4 is a 4. I'm going to take for the other side. So I'm going to remain with 2a plus b being equal to negative 4. I can actually make also b, just this one we have answered part 1. Find an equation satisfied by the constants a and b. This is the equation. Now I can make b subject to the formula. So b therefore is equal to, I'll take 2a the other side, it will become negative 2a minus 4. Even if you write in this form, it is still the same. And then part 2, given further that f of x is divided by, given further that when f of x is divided by x minus 10, the remainder is 10. Find the second equation satisfied by a and b. We'll still use the remainder theorem. Remainder is f of a. Now we've been told if it is divided by x minus 3, so x minus 3 also get to equate that to 0. So find that x is equal to 3. Now here they've told us the remainder is 10, so where there is arrow, put 10, and that will be equal to, in the function f where there is x, will put 3. 3 to the power 3 minus 3 to the power 2 plus a multiplied by 3, and then plus b. Do you have any question? Okay, so here we'll continue. We'll say 10 is equal to 3 to the power 3, that is a 27, and then minus the 3 to the power 2 is what? It's a 9, and then plus a 3a plus b. So 27 minus 9, this is 18, isn't it? And then 18, we'll take it the other side. So it will be negative 18. So it will be 10 minus 18, which is negative 8. And that will be equal to 3a plus b. So this is the other equation. I can make also b subject to the formula. So b then is going to be negative 3a minus 8. That will be the second equation. Okay, just a moment. My network has skipped. Just a moment, my network has skipped here. Okay, so sorry for that. Have we followed it up to here? Can Okay, thank you. So when we reach at this point now, part 3 is saying find the values of A and B. For us to be able to find those, we can see this one is B is equal to, this one is also B is equal to, so we can basically equate them. So say negative 2A minus 4 is equal to negative 3A minus 8. If I take the 3 the other side, it will be positive 3A minus 2A, which is going to give us A. If I take 4 the other side, it will be 4 minus 8, which will give us negative 4. And then we'll also find B. To find B, we can use any one of these equations. So B is going to be negative 2 multiplied by negative 4 minus 4. So CB is going to be positive 4. So that is it. And then using your values of A and B, solve the equation f of x is equal to 0. Now we know that f of x is going to be x to the power 3 minus x to the power 2, and then where there is a we put negative 4x and then plus 4. Yes, Esther.
So how did we get the value of B? I didn't get it.
We've substituted the value of a in this equation, which is we found a to be negative 4, so we substitute negative 2 times negative 4, which is positive 8, and then positive 8 minus 4, that is a 4.
Okay, fine.
Okay, so this is what we are going to have as a new equation. Now we want to solve the equation f of x is equal to 0, meaning that this will become x to the power 3 minus x to the power 2 minus 4x plus 4 being equal to 0. Now to make things easy, already we know that one factor of this equation, it's already been given. I could have used another method, but you will not see. Otherwise, you can tell that this and this will give us basically the same thing if we factorize those two like that. But that will not always work unless it is special like this one. But what we know is that x my what is that x minus 2 we can see is a factor from what we've been told. So if x minus 2 is a factor, you can equate x minus 2 to 0, find that x is equal to 2. Using the synthetic method, we are going to find the other factor. So I'm going to get the coefficients of this function here. Coefficient of x to the power 3 is 1, x power 2 is negative 1, x is negative 4, and then we have got 4. So the first thing, I'll just put a 0 down here. 1 plus 0, that is a 1, and then get this one multiplied by the 2 outside, that is going to be a 2. Negative 1 plus 2, that is a 1. 1 times 2, that will be a 2. Negative 4 plus 2 is a negative 2. Negative 2 times 2, that's negative 4. So this one is the remainder. If we say 4 plus negative 4, that is 0, which is the remainder. Meaning if we factorize this function which is here, the first factor already we can see comes from x is equal to 2. We'll take to the other side, that is x minus 2. The other factor is here. So this is going to be the coefficient of x power 2, this will be the coefficient of x, this will be the constant. So since the first we started with at the power 3, then the next the power is going to drop by 1, that's why we are saying x power 2. So if the highest power was power 4, meaning if you use the synthetic method, this would be power 3. So that is x squared plus x minus 2 is equal to 0. Are we good here? Alright, so since no one is speaking, that says we are good. And then again we're going to find the
We are good,
product.
sir.
Okay, we're going to find the product and the sum of this quadratic. The product is negative 2, the sum is 1. So two numbers we can multiply to get negative 2. If we add them, we get 1. That should be 2 and the negative 1, meaning that we can factorize this as x minus 1 and then x plus 2 is equal to 0. So finding this equation, just equate each term to 0, then x is going to be equal to positive 2, or x is going to be equal to positive 1, or x is going to be equal to negative 2. So these are going to be the solutions to the equation. Any question? Are we good, or there are some questions? Alright, we are good. The next one saying sketch the graph of, might not be clear, saying f of x is equal to x to the power 3 minus 3x to the power 2 minus 9x plus 2. We want to sketch this graph. So the first thing is we need to factorize this function. And we can use trial and error. Let's try to put a 1 here. 1 minus, where there is x, we try to put a 1. 1 minus 3 minus 9 plus 2. Is that going to give us a 0? No. So let's try to use negative 1. If I put negative 1 here, I'm going to get negative 1. If I put a negative 1 here, I'll still get negative 3. If I use negative 1 here, I'll get a positive 9, then plus 2. Is this going to give me a 0? Also no. 1 and negative 1. Therefore, let me try 2. If I put a 2 here, 2 to the power 3 is 8. Minus, if I put a 2 also here, 3 times 2 squared, that is a 12. And then if I put a 2 there, will be 18, and then plus 2. So this is giving us 8. I can simply start with 8 plus 2, which is a 10, minus 12 minus 18. That's not a 0. I can try negative 2. Negative 2 power 3, that's a negative 8. Negative 2 squared times negative 3, that will be negative 12. Negative 9 times negative 2, positive 18, and then plus 2. So negative 8 minus 12, that's negative 20. 18 plus 2, that is positive 20. So this is giving us a 0. What value did we use? We used x being equal to negative 2. So I'll say x is equal to negative 2. This is a factor. Using synthetic division, I'm going to find other factors. I'll get the coefficient of x power 3, which is 1, coefficient of x power 2, which is negative 3, coefficient of x, which is negative 9, and then the constant 2. Alright, 0 here. 1 plus 0 is 1. 1 times negative 2, that's negative 2. Negative 3 plus negative 2, negative 5. Negative 5 times negative 2, say 10. Negative 9 plus 10, negative 1. Negative 1 times negative 2, positive. That's a positive 2. Have I done the right thing? Okay, let me do this again. Negative 9 plus 10, this is a positive 1. 1 times negative 2 is negative 2. So the n should always give us a 0 because we know that x minus 2 is supposed to be a factor. So meaning if I factorize f of x, what I'm getting is this one. I'll take to the other side, so it becomes as x plus 2, which is a factor. And then this one, this will be x power 2, this will be x. So that is x power 2 minus 5x, and then plus 1. Now, are we able to factorize this? That should be the question. Are we able to? So we can see the product is 1, the sum is negative 5. Do you have a number, two numbers we can multiply to get 1? If we add, we get negative 5. I don't think so. So meaning that for this one we can use, let's try to see if it has got solutions. How do you tell if a quadratic has got solutions? You use the quadratic formula or the discriminant. So all you are interested in seeing is the discriminant d, which is b squared minus 4ac. If it is negative, then this means that this doesn't have solutions. So b squared, b is negative 5, squared minus 4a is 1, c is 1. So this is going to be 25 minus 4, which is 21. Oh, the discriminant is positive. meaning that this has got solutions. So we can actually find those solutions. So what are we going to do in this case? So at this point where we've reached, we need to find the x and y intercepts. How do you find x-intercepts? X-intercepts happens when y is equal to 0. So we'll say x plus 2 and then x squared minus 5x plus 1 is equal to 0. This one, if we equate to 0, we're going to find that x is equal to negative 2, or x squared minus 5x plus 1 is equal to 0. So we need now to solve that one using the quadratic formula because we can't factorize it. So x is going to be negative b plus or minus the square root b squared, negative 5 squared is 25, minus 4a is 1, c is 1 over 2a. So this will give us x being 5 plus or minus 25 minus 4 is a 21. Do we have square root of 21? Esther, how many times does 3 go into 21? No answer. So this is going to be the values of x. These will be the x-intercepts. And then the other thing that we can determine is the y-intercept. Now the y-intercept happens when x is equal to 0. So just get this constant. This is the y-intercept, meaning that y is equal to 2. At this point, we can sketch. So just put the x and y intercepts. Y intercept is a 2. The x intercept we found the negative 2. We've also found these two values. Now you just need to know the approximate value of this one. We know square root of 21. We can't find that, right? But get the nearest square number to 21. We have got 16 and 25. 16, square root of 16 is a 4. Square root of 25 is a 5. So let me use a 4. I will use the smallest. So let me say square root of 21 is giving me 4 point something, but let me just use a 4. So 5 plus 4, that is a 9. 9 divided by 2 is about 4.5, meaning that this value is a bit bigger. So it's going to be somewhere here. That is where we're going to find 5 plus square root of 21 divided by 2. And then let's say this is again a 4, so that will be 5 minus 4. I use now the negative. That will be a 1, and then 1 over 2, that is a half, meaning that this one is smaller, like it's going to be below the negative 2. It will be somewhere here. That is what? 5 minus square root of 21 divided by 2. So these are the points where the graph is going to cut. Here, 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 and then it's also supposed to cut through here. Now you can just use one, like just to see the behavior in one function. Let's say when x is smaller than negative 2, just that is enough. Okay, maybe that is a bit of hard. Let me say when x is between 0 and 5 over 2, I can get a very simple number because I don't have a calculator. I can get 1. I'll put 1 here, put 1 here. So that will be 1 minus 3 minus 9 plus 2. 1 minus 3, that is giving us what? Negative 2. Then minus 9 plus 2. It's giving us negative 9, meaning that when x is 1, the function is going to be negative, meaning that it was going to be below the x-axis. So when x is 1, we are finding that the function will be somewhere down here. Now, how is the function going to move then? Now, again, let me just try to confirm something, because from what we are able to see on the intercept, it means that the function can go like this. It goes like this, and then it comes like this, and then again it goes like this, and then it goes and passes through this point. Of course, this is not a turning point, so I should not make it as the point of turning. It can go like this. Just make sure that it is a curve. Okay, it can go like this, or it can go like this. But if it goes like this, can you notice that it means that it will not pass through 2? So meaning that the function can't go like in white. So the function is going to be as the one that I've put in what? In orange or whatsoever if it's yellow. So meaning that the function as a sketch is going to go like that. Just turn it at this point. It goes like this. And then it passes through this point and then continues to go down. So this will be the sketch of the graph of f of x. So what points are going to be marked? X-intercepts and the y-intercept. Those are the points which are going to be marked. Any question? Okay, so there is no question. Let's consider this one as a last example then. Given the polynomial p of x, for this polynomial it has got highest power as power 4. P of x is 6 x with power 4 plus x power 3 minus 8x power 2 minus x plus 2. First question is saying factorize completely. So to be able to factorize, the first thing, use the trial and error method. Okay, try 1. So if you put 1 here, that's just 6 plus 1, 7 minus 8, negative 1, minus 1, negative 2, plus 2, that is a 0. So we are saying that if we use 1, this function is going to work. So I'm going to say x is equal to 1. Then I'm going to get a coefficient of power 4, which is 6, power 3, which is 1, power 2, which is negative 8, x, which is negative 1, and then the 2. Write a 0 there. 6 plus 6, 0, 6, 6 times 1, 6, 6 plus 1, 7, 7 times 1, that's 7, negative 7, negative 8 plus 7, negative 1, negative 1 times 1, negative 1, negative 1 minus plus negative 1, negative 2, negative 2 times 1, negative 2, and then at the end we see the remainder is going to be 0. Yes, Esther. Which negative? Esther, which negative? You can go on. You've stopped speaking. Okay, so this is telling us that this function is actually going to be equal to, we can see x is equal to 1. I can write it as a factor as x minus 1. Now because the highest power is power 4, meaning that this is going to be power 3, this will be power 2, this will just be x power 1, and then this will be a constant. So I'm going to have x power 3 plus, oh sorry, there is a 6. going to be 6x power 3 plus 7x power 2 minus x minus 2. And then we also have to use try and error to be able to factorize this one because it's also a polynomial. We look for a number that is going to give us also a 0 for this part. So let me try one. 6 plus 7, that is going to be 13 minus 1 minus 2, it will not give us 0. Let me try negative 1. Negative 1 to the power 3 is a negative 1 times 6, that will be negative 6. And then x, which is negative 1 squared, is still positive 1 times 7, that will be 7. And then here negative 1 times negative, that will be positive 1, then minus 2. So negative 6 plus 7 is a 1, plus 1, 2, minus 2, 0. So this one has also given us 0. What did we use? We used negative 1. So I'll say x is equal to negative 1. And then I'll get the coefficients. We have got 6, got 7, negative 1, negative 2. I'll put the 0 down here. 6 plus 0 is 6. 6 times negative 1, negative 6. 7 minus 6 is a 1. 1 times negative 1, negative 1. This will give us negative 2 times negative 1. That will be positive 2. So the remainder is going to be a 0 here. So meaning that this is the quadratic which is going to remain. So I can also write this as, first we have got x minus 1. The next one, let's write this as a factor. The one will go the other side. So that is going to be x plus 1. Okay. And then what remains, because it's coming from a cubic function, this will be power 2. This will just be x. So that is going to be 6 x power 2 plus x minus 2. And then you also get to factorize this. So you can see that is a quadratic. The product is negative 12. The sum is a 1. So what two numbers can we multiply to get negative 12? When we add, we get a 1. Makua, what will be the two numbers? What will be the two numbers? Esther.
3 and 4.
Okay, 3 and 4. So this is going to be 6x squared minus 3x plus 4x minus 2, which is 3x, open brackets, 2x minus 1, and then plus 2, 2x minus 1. So meaning this is going to be x minus 1, x plus 1, and then we are going to have 3x plus 2, and then we are going to have 2x minus 1. So what we have done here is we have factorized completely. Okay, okay, Mako. So we have factorized completely like that. Then for the next one, find the values of x for which p of x is equal to 0. So when p of x is equal to 0, just say that thing you've already factorized, x minus 1, x plus 1, 3x plus 2, and then 2x minus 1 is equal to 0. So this is going to give you x is equal to 1, or x is equal to negative 1, or x is equal to negative 2 over 3, or x is equal to positive 1 over 2. So these will be the values of x. And then the next one, we want to solve p of x is less than 0. P of x is less than 0. Now if it is less than 0, we've already found the critical points. We'll just put less than 0 here, but all the same, you still also need to equate each of these values to 0. Okay, when you do that, now you're going to draw a very simple table. showing these values. So I've got four values that we have found: 2, 3, 4. Okay, let me write another on this side so that I remove this one here. And then we have got four factors which we equated to 0. So I'm going to also write those. Okay, so from here, start always with the smallest. The smallest number we have here is -1, followed by -2 over 3, followed by 1 over 2, and then +1. The factors we equated to 0, we have got x minus 1, x plus 1, 3x plus 2, and then 2x minus 1. Are we, are we moving together so far? Okay, so when we equated x minus 1 to 0, remember we found +1. So if I use any value of x greater than 1 and I put into this function, for example, I get a 2, it will give me positive. Immediately I cross 1, it will be negative. When I equated x plus 1 to 0, I found -1. -1 is going to be the demarcation of signs for that factor. So if I use a value greater than -1, for example a 0, it will be positive. And then if I cross -1, it will be negative. And when I equated this to 0, I found -2 over 3. If I use a value greater than -2 over 3, for example a 0, it will be positive. When immediately I cross the sign, it will be negative. When I also equated this to 0, I found 1 over 2. If I use anything greater than 1 over 2, like a 1, it will be positive. And then if I cross the sign, it will be negative. Now remember, these three factors are multiplying, so I am interested in their product. So the product of signs: negative, 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 positive, negative, positive, negative, negative, negative. This will be positive, this will be negative, this will be positive. Now we're interested where the function is less than 0. What do you mean by less than 0? It is negative, where the function is negative. So it is from here up to here, okay, and then from here up to here. So meaning that the solution set is going to be -1 comma -2 over 3 union 1 over 2 comma 1. If it was greater than 0, the solution set would be from -infinity to -1 union from -2 over 3 to 1 over 2 union from 1 to infinity. Those would be the solutions, but it is less than 0. These are the solutions. Now let me just add something. Let's say if they said sketch the graph of p of x, how would we sketch it? So after you have done everything that we have done here, the sketch of the graph would be very easy. So just get the values that we have found and put them on this number line, sorry, on the x or y plane. We have got +1, we have got -1, we have got 1 over 2, which is somewhere here, and then we have got -2 over 3. -2 over 3, excuse me, So negative 2 over 3 is about 0.66, meaning that it is just slightly above negative 1 over 3, like that. So it will just be somewhere there. So it's going to pass through here, it also passes through here, passes through here, passes through here. Also look at x-intercept. Just look at the function itself. That value doesn't have x, that's the y-intercept, which is a positive 2. Let's say it's here, that's a positive 2. So to sketch this graph, you can see, for you look at the product for values of x smaller than negative 1, the function is positive, meaning that it's above, as long as we are less than 1. For values of x between negative 1 and negative 2 over 3, the function is negative, meaning that it is below the x-axis, so it will be down there. Now just make sure that the graph is that smooth. It should make a curvature or a 10. Okay, and then between negative 2 over 3 and 1 over 2, we can see the product is positive, meaning that it's above. It's supposed to go like this. Remember, it's supposed to pass through negative 2, and then comes something like that. And then between 1 over 2 and 1 is negative, meaning that's supposed to be below here. And then from 1 to infinity is positive, meaning that's supposed to be above. So basically this is how the function is going to be moving. It goes like this, comes like that, goes again, and then goes again. So basically that is how it's going to be looking like, and that is how you get to sketch this function.